Hi everyone, today's lesson is on Pythagorean identities and some reciprocal function identities that we learned the other day. So what is a trig identity? In mathematics, a trigonometric identity are equalities that involve trigonometric functions that are true for every value of the occurring variables, where both sides of the equality are defined. What that basically means is that if you have an equation, the left side is always going to equal to the right side. You also could use, by this word right here, an identity, you can use identities to simplify expressions as well. These three functions down here are all inequality, they're all identities, but basically for these, you've got cosecant, these are reciprocal functions, something that we've already done, but we are going to be using our reciprocal functions within our identity chapter. So remember what those are. We have cosecant of theta is equal to 1 over sine of theta. Secant of theta is 1 over cosine, and cotangent of theta is 1 over tangent of theta. So we also had some other reciprocal identities or identities that we talked about last chapter. And one of them was tangent of theta is equal to sine of theta over cosine of theta. Why is that? And the reason for that would be, let's say you had a right triangle, and in the first quadrant, we would be going across and then over. This value going across is your cosine value. This is your x value here. This value going up, of course, is your y value. Well, if tangent of theta is y over x, that would be the same thing as saying that's sine of theta over cosine of theta. Now, a lot of you remember that when you had your unit circle, let's say this point right here, that point was 0, 1. This first value, that's your cosine value. This second value, that's your sine value. And so sine meaning y, cosine meaning x. So that's sine over cosine. You also have another one that would be reciprocal function for this. Instead of it being sine over cosine for tangent, it would be cosine of theta over sine of theta, okay? So we have some even and odd identities. So for these right here, if you think about this and you were to draw a graph of a sine wave starts at 0, ends at 0, goes like this. But this value here, what that value inside in front of the x here means is that you are going to reflect that across the y-axis. Well, if you were to reflect this across the y-axis, okay, this being a continuous function, over here is negative. This value is going to be negative sine x. Whereas if I had had a cosine wave, so a cosine wave starts high, ends high like that. But if I were to reflect it across the x-axis with this is the same function. And in this case, these are both positive. So cosine of negative x reflected across the y-axis is also positive cosine of x. Now, with tangent, if tangent of x is equal to sine of x over cosine of x, then tangent of negative x is going to be negative sine of x over cosine of x, which is going to give me a negative value. So that's going to be a negative tangent of x. Okay, so we have several others, but mostly what you need to understand is that these three right here are negative sine, positive cosine, negative tangent. These are they're reciprocal functions. So sine, of course, is going to be negative. Even if you flip it over, it's still negative. The reciprocal function for cosine is going to be positive, and for tangent will also be negative. So looking at some Pythagorean identities, that's what we're going to be going through today. We're going to apply this to trig. And again, we know that this is our cosine value, which is x. We know this is y. And this is 1, meaning it's our unit circle. So that would be a 1 unit radius. We know that x squared plus y squared is equal to 1 squared, okay? Using Pythagorean theorem, but replacing x with cosine and replacing y with sine, you would get cosine squared of x, or theta, plus sine squared of theta is equal to 1. This one right here is our first Pythagorean identity that you do need to remember. There's this one. Now, a couple of things. There are 3 of these that we do want to remember, 3 different identities. They all stem from this first one. So from the first one, if we were to take cosine squared of theta plus sine squared of theta equals 1, and I were to divide everything by, let's say, cosine squared of theta, okay, I would get cosine squared of theta over cosine squared of theta plus sine squared of theta over cosine squared of theta equals 1. And don't forget to multiply that or divide that on this by cosine squared of theta. I would get cosine divided by cosine is 1. So that's 1 plus sine divided by cosine is tangent is equal to 1 over cosine, which is secant. And so this is now my second identity that I need to remember. The third identity is if I were to take the original identity, which is sine squared plus cosine squared equals 1. And let me do that over here. So again, I'm going to go sine squared of theta plus cosine squared of theta equals 1. And instead of dividing it by cosine, I'm actually going to divide everything by sine squared of theta. And in doing that, sine squared, I'm going to get 1. This is my third one. So I'm going to get 1 plus cosine over sine. Well, that's cotangent. So cotangent squared of theta. And then 1 over sine is going to be cosecant squared of theta. So by just knowing this one right here from my unit circle, I can derive the other 2, and now I have all 3. Now, the 3 Pythagorean identities, so the first one is sine squared of theta plus cosine squared of theta is equal to 1. The second one being 1 plus tangent squared of theta is equal to secant squared of theta. And the third one is going to be 1 plus cotangent squared of theta is equal to cosecant squared of theta. Now, for all 3 of these, and then we just derived those here, okay, all 3 of those actually have can be rewritten different ways as well. So like this one, the first one right here, I can rewrite that. I can say, well, I can solve, or I can isolate the sine. And I could say, well, sine squared of theta is equal to 1 minus cosine squared of theta. And I also could say that cosine squared of theta is equal to 1 minus sine squared of theta. Likewise, with the second one, I can say this, I can isolate the 1, and I'd say 1 is equal to secant squared of theta minus tangent squared of theta. Or I can isolate the tangent, and I could say tangent squared of theta is equal to secant squared of theta minus 1. For this one right here, I could say 1 is equal to cosecant squared of theta minus cotangent squared of theta. Or I can say cotangent squared of theta is equal to cosecant squared of theta minus 1. So for each one of my Pythagorean identities, I have 2 more of those. Now, in addition to that, there's something else that we need to discuss, and that is variations. Okay, now those are my variations, but I'm just going to take one, which is the sine squared of x plus cosine squared of x equals 1. And yes, you can replace x with theta, okay? So for this one, and if I were to isolate the sine squared, I would get sine squared of x is equal to 1 minus cosine squared of x. Just looking at that. Do you remember what this is? This is x squared minus 4. Well, that's a difference of 2 squares, right? X plus 2x minus 2. Or if you had, let's say, x squared minus 1, that would be x plus 1 and x minus 1, right? Well, this right here is also a difference of 2 squares. And what I mean by that is I can actually rewrite that as sine squared of x equals 1 plus cosine of x times 1 minus cosine of x. So I can even rewrite that, Okay, so every one of these, likewise, if I isolated the cosine squared of x, and I had 1 minus sine squared of x, I could rewrite that as 1 plus sine of x times 1 minus sine of x. So really what I'm doing is I'm kind of manipulating these identities into different variations of, what they're equal to. And these all stem from this one identity here. By isolating the sign, I got this, and then I just had to, and then I factored it. Okay, so we're going to start with something simple. Now you're going to be getting two different kinds of problems when you're for identities. One of the types of problems is going to have an equation. The second type of a problem will not have an equation. It won't have an equal sign. So when you do see the equal sign, what I would recommend is that you just simplify one side of the problem until you get the right side equal to the left side. For example, cosecant of theta, its reciprocal function is going to be 1 over sine of theta. And this is going to be divided by secant of theta, which is 1 over cosine of theta. Now, I can write cotangent of theta every time, or I can just write it at the bottom. I'm just going to simplify this side. And always, one of the best, recommendations that I would give you is whenever you see something like this and you see something that's not in sine or cosine, always try to put it in sine and cosine, because that's just going to help you to get to where you need to go. So this says 1 over sine. So we're going to go 1 over sine of theta. Now, this line right here, that means divide. So divide. And then you've got 1 over cosine of theta. Now, division is just multiplication, multiplying by the reciprocal. So we have 1 over sine of theta times cosine of theta over 1, for which I get cosine of theta over sine of theta. Well, cosine of theta over sine of theta is actually cotangent of theta. And what I'm trying to prove, okay, all the way down here, is that this equals cotangent of theta. So I'm just going to box that up because I actually proved that. And we have we've just proved what we set out to prove. And so let's get started on the next problem. This is another equation. So for this problem here, there's two ways that I could do this, okay? There's a really long way to do this, and then there's a super short way to do this. I'm going to show you both ways to do this. A lot of kids see a problem like this, and then they say, okay, I'm going to multiply. So we're going to do that first. So we're going to say secant squared of theta times 1 is secant squared of theta minus secant squared of theta times cosine squared of theta. Now remember, I'm just going to work one side. Now I'm going to change everything to sine and cosine. So secant squared of theta is 1 over cosine squared of theta minus 1 over cosine squared of theta times cosine squared of theta. So that's cosine squared of theta. Now, this is over 1. These are going to cancel and make 1. So now I have 1 over cosine squared of theta minus 1 equals. Now, for this problem here, I see that I have two terms, but I only need one term on the right. So what I'm going to do now is I'm going to try to combine my two terms. So I'm going to multiply this by cosine squared of theta over cosine squared of theta. So now I have 1 minus 1 times that, which is cosine squared of theta over cosine squared of theta. Now, do not cancel these. This is a quantity, and you can't break into that quantity. I could factor it because it is a difference of two squares. I also could think of it as one of my trig identities. Remember this one? Sine squared of theta plus cosine squared of theta is equal to 1. But if I were to isolate this and I said sine squared of theta is equal to 1 minus cosine squared of theta, 1 minus cosine squared of theta, I can replace it with sine squared of theta. So I'm going to replace this right here with sine squared of theta. So now I have sine squared of theta over cosine squared of theta, which is equal to tangent squared of theta. And that's what I wanted to prove, tangent squared of theta. Now this is the long way to do this. What I could have done, okay, is right in the very front, right in the very, very beginning, this right here, that's one of my Pythagorean identities. See that right here, 1 minus cosine. That equals sine squared of theta. So really what I would do if I was to redo this problem, okay, I would say secant squared of theta times sine squared of theta equals, and then I would try to change these into sines and cosines. So secant is 1 over cosine squared of theta times sine squared of theta, which is just sine squared of theta over cosine squared of theta, which is tangent squared of theta, equals tangent squared of theta. So right here, I had so much shorter if I had just remembered, right, to do that. So you need to like keep these in your head so that you know that you're going to be replacing your anytime you see a Pythagorean identity, you can replace it. And your objective is just to get the left side equal to the right side. That's the definition of the identity, is that they're equal values. But it's just getting to that point where the left side equals the right side is kind of the tricky part. So a couple of strategies for simplifying identities. Always try to factor. Transform tangent cotangent to terms of sine and cosine. You can always try to multiply by the conjugate. Remember what a conjugate is. If I had, let's say, 5 plus the square root of 2, the conjugate would be 5 minus the square root of 2, etc. Always look for Pythagorean identities and their variations. Always try to find common denominators. So these are strategies that you can use when you're simplifying identities or proving identities. And those are the two different problems. Whereas the one we just did, if you remember, see this has an equal sign here, right? Okay, so these here are expressions. There's no equal sign, okay? So because there's no equal sign, that being an expression, I'm not making the left side equal to the right side. I'm just simplifying it. So for this one, what I'm going to do first is I'm going to multiply these because none of these are identities. There's no squares, and Pythagorean identities all have squares. So I'm going to multiply through. So I'm going to get cosine of x, tangent of x, minus cosine of x, secant of x. I'm going to change everything to sines and cosines. So now I have cosine of x times tangent, which is sine of x over cosine of x, minus cosine of x times secant of x, which is 1 over cosine of x. The next part here, cosines are going to cancel into 1, and I'm going to have 1 times sine is sine, so sine of x, minus cosines are going to cancel into 1, minus 1. And so that's my answer in simplified version. I don't have to solve anything. I'm not trying to get the left side equal to the right side. I'm not adding in an equal sign when there's not already an equal sign. Don't do that. Okay, so let's do the next problem. This one right here, let's try to simplify this. So I'm going to simplify this by first getting a common denominator. And my common denominator would be 1 plus sine of x. So we have 1 plus sine of x over 1 plus sine of x. And so now I have cosine of x plus tangent of x times 1 plus sine of x all over 1 plus sine of x. So now I'm going to distribute this tangent. So I have cosine of x plus tangent of x plus tangent of x sine of x all over 1 plus sine of x. And so the next thing I'm going to do is I'm going to try to get all of my tangents, and I'm going to make everything sines and cosines. So what I have here is I have cosine of x plus tangent, which is sine of x over cosine of x, plus tangent, which is another sine of x over cosine of x, times sine of x. Don't forget, all of this is over 1 plus sine of x. Okay? What I do notice is that these two terms here are already over cosine. And that looks like that's going to be sine squared of x, because sine times sine is sine squared. So I have sine squared of x over cosine x. Here, I want to try to get everything to be cosine of x. So this is cosine, that's cosine, that also. So I'm going to multiply this by cosine of x over cosine of x. So I can simplify the numerator. So what I do now have is cosine times cosine, which is cosine squared of x, plus sine of x, plus sine squared of x, all over cosine of x, all over, remember, don't forget, it's all over 1 plus sine of x. And now what I see is this. I see sine squared of x, and I see cosine squared of x. Well, that's 1. That's one of my Pythagorean identities. So that's 1. So I have 1 plus sine of x over cosine of x, which is this here, divided by, right, divided by 1 plus sine of x over 1. Well, I'm going to multiply that by the reciprocal, so I have 1 over 1 plus sine of x. And as a quantity, this being exactly the same value here and here, those are going to cancel, and I get 1 over cosine of x, and 1 over cosine of x is secant of x. And so now I've simplified this value. I want you to notice that nowhere did I add an equal sign because there's no equation here. This is just an expression, and you're just simplifying that. So for this one, it's another expression, no equal signs. I mean, you can add, let's say, I like to add arrows, like this is the next step. This is where we're going. You can add arrows, or you can just simply draw underneath. Now, this right here is a Pythagorean triplet. Remember, that's going to be sine squared of x plus cosine squared of x is equal to 1. So if I said sine squared of x equals 1 minus cosine squared of x, and I replace that, notice these are off. See this plus, that's minus. This minus, that's positive. And so these aren't exactly the same thing. So what we're going to do is not replace that and take the opposite, which is negative of that. What we're going to do is we're going to factor that. So we're going to say, well, that's cosine of x plus 1, because it is a difference of two squares. And that's cosine of x minus 1. And this is all over cosine of x plus 1. As a quantity, that's a value that's the same. This whole thing is going to cancel with that entire value here. And so now my final answer is cosine of x minus 1. And so all I did was simplify this. That's it. Okay, so that's it. I hope that helped. Introduction to Pythagorean identities. So thanks for watching.